filler time. I'm going to show you some Chaos Constructions demos from the best of Chaos Constructions demo party that we were doing yesterday, but it's so long that we ended up cutting it into different parts. So I'm going to go ahead and start playing some demos, and hello everyone in the chat who joins in meanwhile. So let's get right on it with Chaos Constructions 2011 Invitation by Quite. That was the invitation for Chaos Constructions 2011. Next up we have two demos from the main demo compo. The first one is 1961 by Storm Studios. By some, the best space demo ever made.
Апреля 1961 года в Советском Союзе выведен на орбиту первый в мире космический корабль-спутник «Восток» с человеком на борту. многоступенчатой ракеты прошел успешно. Пилотом является летчик Гагарин Юрий Алексеевич.
Epic. Really great stuff. Next up, we have Energy Basics by D March that won the demo compo. Fast Demo that ended up winning the compo. They not only won the PC compo, they also won the ZX Spectrum compo, Chaos Constructions 2011, with this demo that you're going to see next, Paralactica. It's a me, a Mario. Anyways, moving on to Chaos Constructions 2012. The winner of the demo compo is actually 64K by Fox Text Gen Test. That was 64K by Fox that won the Chaos Constructions 2012. Fox has a long legacy of winning combos at the Chaos Constructions with 64Ks, so he kept the legacy going. This is the second place entry called Utul by Quite. Really cool demo. I didn't actually know it. I'm gonna add it. Oh, no, no, no. Go back, go back, go back. Gonna add it to my list. Oh, come on. Stop clicking the wrong places. Gonna add it to my list of ambient demos. Cinematic stuff. Please find it. There we go. Because I have a playlist for this kind of stuff. And this demo wasn't on it. And it needs to be on it because it was pretty cool. Anyways, moving on to the next demo on the list. We're going to move on to some 256 bytes. Actually, 256 was a bit divided if it was 512 or 256. This one is 256 bytes. It won the Chaos Constructions 2012 256 bytes competitions. Curiously enough, Chaos Construction became quite famous for some size coding stuff later on, and I think this was one of the entries that really started picking up that trend. So this is by f square root, I guess it's the way you say it, function square root, I don't know. It's called Gitter, and it's just this, but for 256 bytes, it's pretty damn impressive. Next up, we have Recycler by The Super, which is the winner ZX Spectrum demo, and it's really kick-ass. Got a lot of positive feedback. I think you guys will really enjoy it if you don't know it yet. Okay, moving on to Chaos Constructions 2013. The first entry we have to show you is the Cambrian Explosion by Hoi Program. It got first place on the ZX Spectrum demo compo.
For £2, I have bought the central processing chip for the Sinclair computer. No one's asked me where I'm from. I could be a Russian spy exporting that bit of hardware to do something devious with it.
It's real time. It's growing real time.
Next week we'll be talking about the moon. Thanks for listening.
Thanks for listening. Next up, we have a 1K entry, Make Demos, Not 1K Intros by Demarch, which I guess is self-referenced in some way. Was about to say that it kind of repeats itself, but it kind of stopped repeating itself. So yeah, we're gonna get the seminar started. Let me try to open up VLC and put the video. We have a video recording, and it should be around 1 hour, I believe. And after that, we'll have some Q&A. And if you're feeling lucky, we'll have extras for like 10 minutes of something that I cannot reveal. So we'll have to see what that's like. So I'm gonna load up the VLC of Porocyon stock. It's gonna be okay, have it on screen already. So I guess I'm just gonna read this: Introduction to Democoding on the Nintendo DS by Porocyon. And I'm gonna open up this other thingy here. But it's already 9 o'clock, so I guess we can get started. Please enjoy the seminar. It's going to be a little bit techy, so if you're looking for some heavy entertainment, well, I guess if you like hardware information and coding intricate stuff, this is highly entertaining for you. If not, you can come back in about 1 hour and we'll play a few more demos from Chaos Constructions. But please stick around. I think you'll enjoy the seminar. So let's keep going. Yeah, if you have some questions, Porocyon is on the chat, so feel free to just type on Twitch, preferably. If you're watching this through Periscope or YouTube, you should probably come into Twitch and see stuff there. So let's get going.
Hi everyone, I'm Burr of K2 Titan. Thanks for attending this seminar. Today I'll be talking about how to make demos for Nintendo DS because, well, I find it an interesting platform to code for, and I'd love to see people make more demos for it, and I also want some competition because currently I'm the only one making demos for it. Also, thanks for PS for allowing me to basically brain dump about a subject I care about because he just asked me, so that's nice. So first I'm going to give a little introduction, which I'm currently giving. Then I'll start with an overview of the tool chains you can use for compiling your code. Then I'll give a broad overview of the hardware and then go into each of the components in more detail. And then if we have enough time, I can talk about some extra things which might be interesting. So, who am I? I'm a democoder at K2 Titan, and I made a few DS demos, which most of you will probably already know, but also I contributed a few small things to Melon DS, and I'm also working on some larger stuff at the moment, but that's not finished. I also found a few undocumented things about Nintendo DSi, which aren't really that important, but they're interesting to know. And I'm currently also working on dumping the DSi boot ROMs because nobody has managed to do so yet, so that's also an interesting project. But if I wanted to talk about this, then I basically have another entire seminar to fill, so I'm keeping it to basics of Nintendo DS democoding for now. Well, why Nintendo DS? I find it an interesting place between old school Super NES-like PPU stuff, and it also has a PlayStation 1 style GPU, so it sits in an interesting place between completely old school and completely new school. Also, the hardware is completely underutilized. It has a much more potential than has currently been used. It's also fun to code for, except when it's not, but I might be biased. As an example, I will be using this nice compo filler, which I entered at revision, which is mostly normal stuff, but it has a few interesting things which are interesting to look at. And the source code is online at this URL. The slides themselves are also put online, but the link to that is put at the very end of the presentation, so you'll have to wait for that. So how do you even get started with coding for a Nintendo DS? The most often toolchain is called devgit arm, which can be downloaded from this link. It's GCC with a few small patches for mostly 3DS stuff, though you can also just use a regular GCC or LLVM if you prefer that, but then you'll also have to write your own linker scripts and C runtime files. There's libnds, which provides all the hardware initialization routines and also easy interrupt handling and some other stuff like reading data from your cartridge ROM image. For testing your code, you typically want to use an emulator simply because it's easy to iterate on stuff. The two most well-known emulators for DS are NoCatch GBA, which is the first good one. It has a built-in debugger. It's technically Windows only, although it usually works in Wine. Sometimes it doesn't, but oh well. There's also Desmimi, which is cross-platform. It doesn't have a debugger, and it's also not really maintained. There's also a new one, MelonDS, which is cross-platform-ish, although it doesn't have code for macOS yet, but that's not too hard to add. It doesn't have a debugger yet, although I'm working on that stuff. It's not completely finished, it has some rough edges, but it's getting there, although I might be positively biased on it. There are also a few new ones coming, although they aren't completely usable yet. And the Ansata debugger is the official one. You might have heard of it, although it's not very good at all, so you're definitely better off using one of the others. To test, well, an emulator is good for quick iteration, but it isn't, well, none of them are completely accurate, so you always want to test on real hardware. Usually, well, back in the day, you had these flashcards, such as the R4 or the ACE card, and numerous others. You can still get them for cheap, second-handed, but also, if you have a DSi or a 3DS, you can jailbreak it, and then you can load ROM and DS-ROM files over the SD from your SD card, or use a small program which then loads ROM over Wi-Fi, which is incredibly useful. Although these Wi-Fi transfer programs have a few limitations. There's DS-Link, which only uses web, because that's what the Nintendo DS hardware chip for Wi-Fi supports, because it's old. On DSi you can also use Wi-Fi boot, which supports WPA, which is great because nobody uses web anymore for a good reason, although it isn't very reliable. There's also a problem of flashcards and all the other stuff. They really don't give you a fixed set of initialized hardware stuff. It varies a lot between flashcards or the jailbreak entry point you're using. So you always have to initialize all the hardware. libnds does this for you, but this also means that intro coding and size coding on the DS is not really possible. Also, this means that file loading isn't uniform, because one time you have to read from the SD card, the other time you have to talk to the cartridge. So you also have to use the routines provided in libnds, because otherwise it won't work for other people. Also, most of them won't give you the extra features of Nintendo DSi, such as a faster ARM CPU and a bit more RAM, but that might not always be needed. For information, very detailed information about the hardware, GBA tech is basically what you want. It's incredibly detailed. It's not completely correct. There are some corrections on the Melon DS forum. Example code you can find, well, it comes with DevKit Pro, and there are also some demos with source code published. Although coding guides themselves don't really exist. Well, there's Tongue for the GBA, which is quite good, and most of the stuff still applies, but it doesn't teach you about 3D because the GBA doesn't have a GPU. So what's actually inside of this Nintendo DS thing anyway? And for that I'm going to go back to the old Game Boy days. The Game Boy and the Game Boy Color had a simple Z80-ish CPU with a few Ks of RAM, and its CPU had a few tiled backgrounds, a few sprites, raster interrupts, all the good stuff. Basically anything you need to make a demo. It was just nice and good. Then the GBA came around. It had an overhauled PPU. It has a pretty strong ARM7 TDMI, which is nice and easy to code for, which is why in the early 2000s you had quite a number of GBA demos. Its PPU has more and larger backgrounds, more sprites. It basically still used all the concepts for all the graphic stuff, so it was clearly influenced by the Game Boy. But it did have new stuff like windowing, blending, and Mode 7 effects, which were taken from the SNES. To illustrate that, it actually has two ARM chips, one ARM7 from the Game Boy and one ARM9, which is basically the next ARM generation, which is by now still quite old. This is not a simple multiprocessing system like you might find in a PC. The ARM7 can only access the audio hardware and a few miscellaneous peripherals, which are not interesting for demo coding. The ARM9 is the only CPU capable of accessing the graphics hardware, and it also has a cache, unlike the other one. There's, even for 2005, no SIMD, no FPU, no new fancy stuff. All of the buses are 16-bit and they are 33 MHz, even the bus for the ARM9, which means that if you have to talk to the hardware, there's some slowness involved in that. And it has 4 MB of shared RAM, and each core has a few K of internal RAM. The shared RAM is really slow, so you definitely want to optimize some things and put the important code and data in the caches or locked cache or the internal memory. Per CPU you also have 4 general DMA channels to copy stuff around. You also have 4 timers per CPU, which is useful for timing stuff or causing an interrupt in this amount of milliseconds. The interrupt system is basically the same as on the GBA, which is, well, it still has, you know, the LYC stuff from the Game Boy, except it's renamed and it has to go through all the ARM interrupt handling stuff instead of the Game Boy interrupt handling stuff. There's also an IPC FIFO thing so the two ARMs can communicate with one another. It's, well, not very good at synchronizing stuff, although libNDS wraps around it so that it becomes useful. For the graphics, you know, one screen is basically a GBA PPU, so you have 2 of them glued together in a trench coat. Except they have more VRAM-ish. The GBA had a fixed amount of VRAM. On Nintendo DS you have a number of VRAM banks which can be configured and mapped to a specific purpose. I'll get into that soon. The screens are divided into a main screen and a sub-screen. Usually you have one for the top and one for the bottom, but you can choose, you know, which one goes on which screen. GPU has basically the same capabilities as the one in the PlayStation 1, except it's worse. You can use it as the background number 0 for the main screen, or you can just put 2D stuff there and then you cannot use a GPU. The main screen also has a few extra things. You know, its output can be captured, and it also has a few extra display modes to DMA stuff straight from VRAM or from MARAM directly into the LCD output, which might be useful sometimes. For audio, it has, you know, basic 16 PCM channels with 16-bit audio and the 32 kHz sampling rate, which is quite nice. It can also play 80 PCM samples, which is a bit like SNES BRR except worse, and it can also play PSG sounds, which is, you know, the old Game Boy style sound effects. It can also use a capture or a feedback stuff for certain channels, which is not to be confused with the internal microphone. That's a different thing. So that's useful for a few effects, although I'm not sure how much this is used. And again, for memory you have a few small things. There's, you know, large slow memory. You can also technically use the sprite or the palette memory as memory. One thing to note about this is that it's all the VRAM or VRAM-ish memory will ignore 16-bit writes. So you have to use it will ignore the 8-bit writes, so you have to use 16-bit writes because that's the size of the bus. The Game Boy and the Game Boy Advance had the ROM image completely mapped into the memory. This is not the case anymore with the Nintendo DS, so you have to use some special stuff there. Also, the address logic is really simple, so you can, you know, the 4 megabyte shared memory is repeated every 4 megabytes in its region. The smaller memories are repeated even more often, etc. Which is actually, you can use it to see whether you're actually running Nintendo DS or on the GBA if you have just a blob of ARM code, which is kind of interesting. The ARM9 also has an MPU which can be used to control caching, or you can actually fault on certain memory region accesses, although on the DS this is not very useful because it cannot run an operating system. It also cannot do address translations, so it's not an MMU. And then there's VRAM, which is annoying and complicated. The details, I'll get into that in a second. The DSi also has new WRAM, which can be assigned to one ARM instruction. That mapping is really complicated, and I'm just not going to talk about it because no. And interesting to note here is also the DSi is basically the Nintendo DS with an overclocked ARM9, although the bus speed is still 33 MHz, so that's not very useful. It has more RAM, it has the new WRAM stuff, it has a few extra things which are not always very useful. And the 3DS, it's basically you take all the new DSi stuff from the DSi, you remove all the Nintendo DS stuff, and then Nintendo built a completely new console with that, which has an actual powerful ARM11 with an MMU, so you can run an operating system on it. It has quite a bit of memory. It has an actual GPU, which can do actual GPU stuff instead of the weird thing the DS has. It does not have the PPU anymore. It uses different interrupt stuff, so all the legacy from the GBA and the Game Boy is gone, sadly. It's much more powerful than the DS. And there's actually one interesting thing. Because of they kept all the DSi hardware, which has some bugs in it, you can still use those bugs in the 3DS, which actually has been used to jailbreak it. Alright, on to graphics for the DS, and also the totally, absolutely horrible VRAM mapping. So, this is an overview of how the graphics stuff works on Nintendo DS. You can see there's a 2D graphics engine A and a 2D graphics engine B. That, combined with its layering and special effects, is basically an SNES or a GBA. It has a whole other lot of stuff in it, such as a 3D graphics engine. It can also capture the output of certain things, which also has a built-in blend thing. You can also note that it has settings to change the master brightness, so you can actually fade to black and fade to white, which is really useful if you want to have some kind of transitions in a demo. The VRAM mapping, we finally arrived at this point. I'm going to zoom in a bit. You can see that there are 8 VRAM banks at the top, numbered A, B, C, etc. to I. There are 4 big ones of 128K and 4 smaller ones. You can see that you can give them all a specific purpose, which means they can only be used for that, such as, bank A goes to a 2D background, bank B goes to sprites. You cannot say, okay, the first 96K of bank A will be used for backgrounds and last 32K will be used for sprites. That's not really possible, which is annoying, because if you want to use screen captures, for example, it will have to use 96K, which is the size of one screen on the DS, and it has to be mapped into a specific purpose for that. That means that the bottom 32K or the last 32K of that bank are completely unusable, which is not great. So yeah, there's loads of options, and you can see that not every bank can be used for everything, and it's annoying and complicated. And the way backgrounds and sprites are mapped into VRAM is also slightly complex, because there's not just one setting where you can say, okay, this background will use this memory address and that one. No, you have like 3 different things, like the map base, tile base, and there's a per background, there's also a global offset for stuff, and you have to mix and match them, because here at the top I set both of these bases to 1. If I kept them at 0 at the default, it wouldn't be possible to put this green at the bottom, which is the second background, in the same VRAM bank as the third background, which would have meant that I had to use an extra VRAM bank, which mightn't have been possible due to other stuff I would have been doing. So, display capture, it's useful for simple effects such as this zooming thing in MCMC by the Royal Elite Ninjas. In that scene you basically have this image of which a capture is taken, then it zooms out a bit and you see this again until it repeats and repeats and repeats. You can also blend two sources, so you can have the 3D output as one source and a spare VRAM bank as another source, and you can blend the two, which is usable for example, faking, or, well, it's not even faking, it's even worse, but you can fake motion blur with it, which is quite useful. And as an interlude, how do you even load data from ROM? In your .nds ROM file, there's this thing called the NitroFS, which contains all the embedded files. And because you're either using a flash card or loading stuff from the SD card using a jailbreak, you cannot really just say, okay, I will read from the cartridge or I will read from the SD card. You'll have to use something, and the standard the flash card makers and the homebrew people agreed on is called DLDI, which provides a few functions for basic block operations. libnds wraps around it by having an actual file system driver, and also by providing the standard I/O functions such as fopen and fread to actually be able to read files. So please use libnds, because otherwise it might not work for some people, which actually has happened in the past. You can use NDS-tool, which is included in devgit arm, to it takes your ARM9 ELF file and the ARM7 ELF file, plus all your data files, and just spits out an NDS ROM file for you. And the devgit arm build scripts in the example folder also already do this automatically, so just use that. And you can use this single line of code to magically redirect the fopen and fread stuff to the NitroFS instead of using the internal NAND or the SD card file systems if you happen to be running on a DSi. Now, as I said, the GPU is only available on the main screen, so it's only possible to render 3D stuff on one of the screens. However, often you actually want to use it on both screens. So how would that happen? So a solution to this is to use display capture to capture the 3D output, while on the next frame you actually flip the main as subscreens between the top and the bottom screen, and then you will render the captured output on the bottoms or on the subscreen, and render the new stuff on the main screen while you're capturing that. So, and then in the next frame you flip the two again and display the old one. This needs double buffering because you can't share between display capture and render on the subscreen, so you lose two VRAM banks, which is really annoying, but it works, and it also degrades the frame rate a bit, but it works. It's not exactly a new idea. There's demos from 10 years ago doing this. Also, some commercial games did this. So yeah, there's lots of stuff to be abused, but you really need to think about how VRAM is used before you can actually make an effect. Now, for example, UFO from Planet Slime did the following. For the 3D textures, which is the UFO, but also the starry background, for which I just used a full screen quad because it was easy and simple. Now, 128K bank was used for that. For the 2D backgrounds, which is the actual UFO from Planet Slime text, I used another bank, and then I used two 128K banks for display capture and post-processing because I had a not so completely working Bloom implementation, but it looked okay, I guess. And then, as I'll explain later, I still had to put something on the bottom screen, and I only had these two banks left, which is not very much. Now, I'll do 3D graphics on a DS. The GPU has a very minimal support for OpenGL 1-ish features, kind of. It has a hard polygon limit of 2048, which is not that many. I mean, it's better than software rendering, but still. Textures are maximum 512 by 512 pixels, which is not that much, and it will actually fill up all the 4 large VRAM banks. So you practically want to limit yourself to 256 by 256 texture maps, which fills 1 VRAM bank. You can also use paletted textures, which will decrease the VRAM usage a bit. It has a simple interface. You simply write a command to something called the GX50, which is just a magic address in the MMIO memory. You can either use a software write or do a DMA write, which is very useful because then you can simply export a 3D model completely to the 3D command format, and then DMA the entire thing straight to the GX50, and it will just render it for you, which is what UFO from Planet Slime does for the UFO. And it's also just the most practical way of doing things, though you typically want to write a conversion script for this because there aren't any public ones, and the one I wrote uses too many hex and is actually tuned to the UFO from Planet Slime stuff that it probably will not work for other stuff, so that's why I'm not really publishing it. One thing to notice, libNDS actually has an OpenGL style wrapper around it, though it's not very good and it actually breaks compatibility in quite a number of cases actually, so you might not want to use that depending on what you're up to. Now, the geometry engine is quite basic, although it actually has built-in hardware for calculating matrix transformations, which is good because the ARM is usually too slow to do that if you do it all on the CPU. So typically the matrix transformation stuff is write only, although you can use the clip matrix register things to actually read back a result, which is quite a bit faster than doing it on the CPU. Other than that, there actually isn't a lot to talk about. It's literally just you give it a vertex, it renders the vertex, that's about it. Everything is immediate mode. There aren't even any indexed drawing stuff, like indirect vertex buffers or anything. It's quite basic. The texturing in the rendering engine only supports nearest neighbor interpolation, which is why textures on the DS are often quite blocky. It is perspective correct, unlike the PlayStation, although it has some other problems, such as there's quite a bit of aliasing if the texture is downscaled quite a lot, or if it's far away from the camera. it has, other weird edge cases described in the MelonDS blog. It also has a few weird, very, very specific features, such as anti-aliasing between edges of different polygons, which is a bit weird, but okay. For the lighting, it only supports grow shading using a lookup table. It only supports directional lighting, no point light, so you have to fake point lighting. If you're drawing a model, you have to recalculate all lighting parameters again. It actually has special hardware for fog and for toon shading and for polygon edge marking, which are, specifically made for games on the DS. All of that also use lookup tables, simply because they couldn't really implement a proper GPU, I guess. For shadows, it has very, very limited support, although there's something for it, but most of the burden is actually still on the coder. In GBA Tech, you'll find some information about it, where, you basically render a model and, a backdrop thing, and then the GPU will tell you, okay, these things will be projected here, and then you have to create a new shadow polygon to actually render the shadow, and it's annoying. You still can do a few tricks with it. For example, there's a space cutting effect often seen on high-end Amiga demos, etc. Calculating all the intersections is a bit annoying, so there's a better way to do it, namely you can just fake all of it using textures. If you use some tricky stuff to calculate the UVs, you can actually still use the world coordinates for the UVs, and then you pretty much immediately get this as a result. And there's the toon shading, which uses the lookup table, as I said. How it uses that, it first applies all the regular shading stuff, and then it uses the red channel of the result as an index into that lookup table, which can be actually whatever you want. You can actually also change it every frame, because that's also possible. So with that, you can create some interesting, weird strobe-like effects, which has been used in this prod. So yeah, of course, there are a few ways to get around the polygon count limitation. For that, you can simply split the screen in 2 or 4 sections. And then every frame you render only one section using the GPU, which means you can use 2048 polygons in only that section. And then you use a display capture to put it into another VRAM bank, which can later be used by the PPU. And then you use the PPU to composite, the history of the last n captured frames to composite the entire frame, which will now have way more than 2048 polygons. This has been used in Super Mario Galaxy DS, which is a fan game, not official. It's also eats VRAM banks again, because of course that's what happens when you have to use display capture. And now time for the old school PPU stuff, which is basically taken almost verbatim from GBA, which has been heavily inspired by the Super NES. So it's quite old school. You get 4 backgrounds, which can be tiled or bitmap, and can use palette colors or direct colors depending on which background mode you're in. You cannot freely select it. You have to mix and match, larger backgrounds or more backgrounds versus more bitmap backgrounds, etc. You can also overlay stuff and have a bit transparency, and you can reorder the backgrounds. For sprites, you get 128 sprites per screen, and because the PPU is actually fast enough, you can actually put them all into one line and multiplex them on the entire screen, which is quite nice. It uses pretty much the same formats as backgrounds. Now, one thing to note, if you're using, H-blank raster effects, sprites are always rendered one scanline in advance, which is something you have to keep in mind because otherwise things will not work correctly. So the PPU also has a few effects available. Again, basically stolen from the SNES. One of them is windows, from which you can basically say that, okay, this background or this sprite, its pixels will only be rendered when the coordinates fall between these X and Y values. And with raster effects, you can also shape them every raster line. There's also blending, so you can blend multiple backgrounds or fade a background to black or to white. There's also a mosaic effect, which looks a bit like pixelating things. It's used, for example, when Mario goes through a pipe with the fade out and fade in animation, when things get pixelated, that uses the mosaic effect. There's also HDMA, again from the SNES. It's a special DMA mode, so it will write 2 or 4 bytes every scanline to a selected register. One thing which the SNES does have, but the GBA and the Nintendo DS don't, is indirect HDMA, and they only have direct HDMA. Direct HDMA simply copies, you have a list of values, one for every scanline, and it will simply copy the first for the first scanline, second for the second, and so on. Indirect HDMA, instead of just copying the value, it will use the value as a memory address and then read from that memory address and copy that value to wherever you want. So that's something to keep in mind. And for example, there's this round view thing example that uses HDMA to control the window registers. So at the very top, there's everything is disabled using the windows, and then there's a small hole and it gets larger and larger, etc. So yeah, but if you want to do more complicated stuff, it's usually good enough to use the CPU interrupts because your CPU is actually fast enough. There's also mode 7, although mode 7 is a bit of a misnomer because the GBA and the Nintendo DS don't really have a graphics mode number 7. So yeah, depending on the 2D mode, you can rotate and scale and also scroll some backgrounds. And you can also do this with 32 sprites regardless of the 2D mode. You can, it's famous because you can use raster effects to fake 3D landscapes, such as in this example image. UFO from Plant Slime uses this for the bouncing or jumping or something logo title with the UFO from Plant Slime text. It jumps with the beat. And now we get back to the interesting stuff. As I said earlier, for the compo filler, I only had a really limited amount of VRAM available to draw all the stuff on the bottom screen. So what I did was I took all the text I put into it and I crammed it really crowded on a single texture that only fills like half a screen. It has 4 bits per color or something, which was lowest setting and uses palette indexing. So the text itself, it uses color registers, but also it uses the window effect to only draw the text which is in the middle of the screen and not all the stuff around it, because if it would have been turned off, you'd see all the text everywhere. So yeah. And another interesting thing is, with the text stuff, I had the first row of pixels is completely white because I could only use one color. And I used two backgrounds which used the same VRAM. So one of them is for the text and the other one is for the green abduction beam thing. They use the same pixels, but they have different palettes. So I could, set the one to use white and the other to use green. And then, I hid the single white row of pixels for the text background, and you use the second background to simply replicate it on the entire screen using raster effects. Then I also used the window effect for the other, the abduction beam background to actually shape it into the form of an abduction beam. So that's how that works. Now, all the color stuff is, it has a maximum bit depth if you actually define a background or a texture or something. It has a maximum bit depth of 5. So you have 5 bits for the red, 5 bits for the green, 5 bits for blue, and 1 bit that's sometimes used for transparency and sometimes just ignored. It's, basic Nintendo color format. It's also used on the GBA. It's also used on the SNES. I think it's also used on the Game Boy Color. I'm not completely sure. But the color math and all the blending stuff actually has an extra bit for precision. So that means if you can actually blend 2 backgrounds, you can have more than you can actually have more colors than you can simply store in one background. You can actually make this slightly better by changing palette entries using HDMA. And that's how Super Mario Galaxy DS it's also what it does to enhance its colors slightly. It's not very visible, but the specular shading stuff uses it, for example, to be really bright. And another thing you can do is by using stable rasters to change the parameters of the PPU while it's actually rendering the image. So you're basically raising the beam, but it's also possible on Nintendo DS. So if you turn off everything, it will actually default to output just the background palette number entry 0, which is just a single color. You can just write to it using the CPU, even during active display, so you can change it while it's going. So if you do the math, you have the ARM9, which is quite fast, and the dot clock, which is 12 times slower. If you then write a small check, which checks, did the current scanline number change, in a really tight loop, you can actually fit that within 12 cycles. So it's, within one graphics dot. So there will be a bit of jitter between the scanline actually changing and your code breaking out of that loop, but you can actually tolerate it simply because you have a few cycles of padding left compared to the pixel clock. So if you time your writes correctly, you can make sure that it will always happen within a single dot. So with some careful clock slide and cycle padding magic, you can actually get the writes to be completely stable, which is how that flag is done. I actually needed some extra, well, more caution and more padding simply because on the 3DS there's an extra DMA transfer going on in the background, but if you have time for it, I'll get into that in the extra stuff. So yeah, that's how that prot was done. And because of the timing being very tight, emulators don't do this correctly because the timing is really complicated because there's a CPU which runs on the speed in which it runs depends on which memory it's executing from and also which memory it's reading and writing data from. It depends on how many DMA stuff is running, it depends on the other ARM CPU which might be accessing the shared RAM, for example. It might depend on how exactly, well, there's loads of things that can happen. And there's also caching, which complicates things even more, so there's a reason you want to test stuff on hardware. Also, the emulators currently all render everything in scanlines instead of separate pixels, simply because otherwise things would be way too slow. Alright, we're finally done with all the graphic stuff, so it's time for audio. Actually, there isn't that much to talk about because it's pretty simple and actually quite nice, so I'll get through it quite quickly. It supports 8-bit and 16-bit PCM, 80 PCM, which is some differential, another way to encode samples, which has a bit of compression, but it doesn't always sound very good. There's also the PSG sounds from the old Game Boy days. It has, frequency, sample length, volume panning, and sample looping control. It's pretty simple. You can actually choose to turn on or turn off the mixer. You can capture the mixer output or capture one specific channel, and etc. But how do you actually use this? By default, libNDS provides maxmod, which has simple functions for play this sample or play this module file, which it works, it's useful, and it also has an API for the ARM9, which uses the IPC thing to actually inform the ARM7 that it needs to play certain sounds, which is great because it's nice and easy. Other than that, it's a bit limiting, and if you want more complex stuff, you'll have to do something else. So one thing you might want to do is to use a custom tracker module format with custom renderer, which uses all the Nintendo DS audio features, such as the feedback stuff and the hardware mixing, because I'm not completely sure if maxmod does mixing in hardware, because it also exists for the GBA, and GBA only has 2 channels, so you have to mix all the audio in software. But anyway, creating a custom module format needs a lot of effort, and nobody has done so, because, why would you? Because there's a better option. We still have an ARM7 at 33 MHz at our disposal. It's basically doing nothing. Even, Nintendo's SDK completely forbade developers to even use the thing because they used it as a security coprocessor, which didn't secure anything. So, yeah, what could you do with this? Maybe real-time MP3 decoding. It's actually fast enough to do that. There's several prods that do that, or use Opus instead of MP3, but it works. It actually sounds great, and the musician can basically do whatever. And technically you can also just stream 80 PCM or raw PCM samples, but it's either way too big or the quality is just not very good. So that's it. Go make a demo. I'd love to see NDS demos, or actually any weird console for that matter. I'd really love to have some competition. And with that, are there any questions?
Okay, let's try to get Porocyon on the line. Try to answer some questions for us. Porocyon, are you there? I can't hear you.
Can you hear me?
I can hear you now. Welcome. Thank you so much for that presentation. That was really cool.
Thanks.
I have a few questions that I was noting down as I was watching, so I'm gonna also post them to you so you see exactly what I'm saying in case you have because my microphone was having issues on Discord. So is there a way to capture the Nintendo DS natively? Can you do some sort of output, or do you have the only way to capture demos running on the Nintendo DS is it by aiming a camera at it?
Yeah, right now, if you actually will watch the YouTube videos of all the Nintendo DS demos on Poet, they will either be, physically captured with a camera in front of the physical console, or it will be an emulator capture, which is suboptimal most of the time.
Yeah.
Hardware capture units are available, but, well, they do exist in theory, but nobody has them.
But is there a special output that you could grab into?
Yeah, on the DS, well, on the main board of all the DS consoles, there are some test points with all the pins for all the video bits, and even a bit clock and an H sync and a V sync signal. So that could be used in theory, but then you still have to do a lot of soldering. You'd have to make your own FPGA or hardware that captures it with correct timing and then encodes it into a video file. That's a lot of effort.
Yeah, and you would have to have the NDS open all the time to be able to capture stuff. So yeah, that's a bit tricky.
Yeah, I mean, you could probably make some kind of ribbon cable and then have the console mostly closed, except there will be a lot of wires coming out of it.
Okay, next question. What language do you usually code on? How much of it is assembler and how much is C?
I mean, it's mostly C. Like my code base is 95% C. There's some assembly for, a fast memcpy implementation. There's some math functions that have to be re-implemented because you don't have an FPU, so you have to work around that.
Yeah.
And yeah, there's also with the bloom effect in UFO from Planet Slime, that's the pixel processing function is also written in assembly to speed it up a bit. It's still slow, but oh well. But yeah, other than that, all the actual effect code is in C. The the code that decides when to start and stop an effect, or how a 3D model should move, etc., etc. That's all in C.
All right. How active is the homebrew scene for the Nintendo DS? Do you have an idea? Are there many active people?
It used to be very active. Right now, it's kind of dead-ish. There's one or two other people.
The scene
active.
is always dead. But has the knowledge lived on? Are there forums where they document how to access stuff?
Yeah, that, or there's the Melon DS people who, of course, know a few stuff. There's still Garicom, who's working on GBA Runner 2, which is a GBA emulator for the Nintendo DSi, which is really hard to make, so it uses a lot of dirty hacks. And there's some people working on the SI homebrew stuff, but it's about 10. Well, it's in the tens of people, not more, because
It's a very
there's
niche thing then. Mm.
well, there's another console from Nintendo which was sort of the successor of the DS called the 3DS, and people mostly moved to that homebrew community.
Yeah, you mentioned a little bit comparing the different handhelds from Nintendo. So I think the 3DS is a bit like the DS, but with some extensions. Am I talking shit right now, or is this
Yeah,
correct?
you're absolutely talking shit.
Okay.
The DS is actually a GBA with extensions. The 3DS is like all the DSi stuff. So you have the DSP, the Wi-Fi, the touchscreen controller. That's actually kept from the DSi, but
Mm-hmm.
all the other stuff is completely new. It's a completely new GPU. It's an ARM11 MP core, so dual core or quad core.
Mm-hmm.
The memory map is completely different. No, all the RAM timings are different. Because
Okay.
with the DSi you still had the all the hardware of the Nintendo DS, but you also had the same-ish GPU as a GBA. You had more or less the same video RAM as a GBA.
Yeah.
You had there was still a lot of stuff left from the GBA days, and that was all removed when they started working on the 3DS.
Okay. So yeah, it makes sense that this is more like abandonware kind of stuff or vintage almost. So yeah, other questions that I had for you. You were talking about that it's OpenGL based to some degree. So are there like any engine exporters to the NDS format? You already answered this on the chat, but for the people who are only seeing the video and not reading the chat, could you answer that again, please?
Yeah, it's the 3D API was probably inspired by OpenGL one. It has pretty much the exact functions in the OpenGL spec, or mostly in the 3D hardware commands for the GPU. But it's not completely the same. It lacks a few features. In the features it has a few weird edge cases where it's different, so it's not completely compliant. And wait, there was, what did I actually answer again in the chat? I'm actually also reading back a bit.
Yeah, scroll back. Also talking about the comparison with the PlayStation.
Yeah, that too. It actually has hardware transforms, so you give it the vertices, the vertex coordinates. Those can be 3D, and the hardware will transform them for you, which, as far as I've heard, I'm completely not sure about it. The PS1 doesn't. But it also has a perspective correct texture mapping, which is also great. But then there's other drawbacks it has. So yeah.
Yeah, that's what gave the PS1 its character. All the games were perspectively wrong on the textures. That was so great. Anyways, regarding the music, are there any music trackers that could easily get ported to the Nintendo DS? You said there was nothing, but I would assume that stuff made for the GBA would be somehow easy to port for the NDS. Do you know anything about that?
Yeah, Kusma, who actually did a lot of code for the Shitface Clowns demos back in the day,
Yeah, for
also
GBA.
made, for those GBA's demos, he made Pimp Mobile, which is a module player for the GBA. You could simply take the code, remove the hardware, the software mixer, and make it use a hardware mixer, and it will most likely work on the DS.
Okay, just no one bothered doing that yet?
Yeah, because there's already MaxMod, which is good enough for playing module files.
Mm-hmm.
And other than that,
I think
MP3 replay
yeah,
works. So
if you can use if you can decode an MP3, why bother? But I think like for stuff like sound effects, or if you, how is the
yeah,
timing
if you're
syncs
making a game, you
on the
definitely
NDS?
want to look into this. But
Yeah,
I don't make games, so yeah.
yeah. So fuck that shit. What about if you want to have like sync stuff? Like, is it well because you're decoding the MP3 and you're playing the stuff. How is the replay in terms of timing with the rest of everything? Is it easy to get the timing out of the audio buffer in some way?
It's the audio hardware is actually connected to the hardware timers, but I'm actually not using it for sync. I simply take the the amount of V blanks for timing because that's the highest resolution you need, and it all starts on the exact same moment. So I haven't needed to do it yet because it just worked.
Won't it go out of sync after some seconds?
Not really, because there isn't really a drift because the frame rate is completely fixed, and as long as you can keep streaming the audio quick enough so that it doesn't repeat a buffer or that it starts glitching, which it does, because otherwise I wouldn't be able to enter it in a competition in the first place.
Yeah.
It's also not overwriting the buffers too quick, so it just works.
Okay, great. A couple other questions that we have. What are some of the cool effects that you can pull off on the NDS? Focus mostly on 3D or also doing some tile stuff? Do you have any insight on this?
Right now, I'm mostly most of the demos I've done basically used the 3D engine as a base. Then I used the 2D engine as either some sort of some framing or overlay stuff, or to use it for displaying post-processing effects of the 3D stuff.
I guess you have to be a little bit creative on how you use the elements that you have as well. So it's not like...
definitely, because you could use the capture unit for blending, but also the PPU for blending, and and you can actually also use the H blank effects on the 3D layer. For example, changing the X scroll position of the 3D layer with a random value every scan line, so you get the noise-ish shaking effect, which you can often see in demos. That can be done using the PPU. Does that answer the question a bit?
Yeah, I think so. There was another question being asked meanwhile by Paul Falcão. He was asking how to get the demo in the actual Nintendo DS. I think you covered this on a slide. There's flashcards already available, and you were talking about some way to transfer it by Wi-Fi. Is this correct?
Yeah. So yeah, you can use a flashcard, and those will work most of the time, especially the more popular ones. There's stuff with DLDI that sometimes doesn't work out of the box, so you have to patch all the ROM files yourself, and it's a bit annoying. Yeah, with the Wi-Fi loading, that's just another DS ROM which you can load either from a flashcard or using a jailbreak. And the jailbreak is a bit like a flashcard, except you're using the SD card instead of a flashcard. That's also only for the DSi, by the way, not for the regular DSs.
Oh.
Sorry?
Oh, I said, in admiration of it not being available for the NDS.
Oh, yeah. Yeah, well, technically for the DS, you could still, solder some wires on the SPI flash chip and then, reprogram it with a custom firmware. But, that's not really a good idea, because then things can get bricked really easily.
Mm-hmm.
It also doesn't have an SD card port, so you still have to find a way. And then you could use a Wi-Fi loading thing, except that's only practically usable for ROMs that don't really use the embedded file system within the ROM, because first of all, it probably won't even fit into the main RAM.
Okay.
Secondly, it's also most likely not equipped to deal with running from RAM completely instead of from a flash card or from the SD card.
Okay. So I'm assuming this means that the best option is usually flash card. If you
Yeah, I mean, the
want to keep
Wi-Fi
it
loading
simple.
stuff is really great for prototyping and testing stuff, because then you can simply take all the files that you would put into the ROM, but just on the flash card or on the SD card, and simply reload the file over and over again over Wi-Fi until you have tweaked all the numbers to whatever you want it to be.
Mm-hmm.
Yeah, I think that's about it.
Yeah, that answers the question. Another question on the chat: how does the GPU trick to display more polygons work exactly? Is it hard to work with?
Yeah, so for that, you first have to set up a few. Well, no, for that, well, let's talk about the case where you just split the screen in two halves, so that you simply double the amount of polygons you can work with. So you have to set up two VRAM banks to be capturable, and set up the display capture in where it takes the PPU combined stuff as a source, and it just renders to one of the two banks. Then you set up the 2D backgrounds so that you can see, so that those also use those banks. And then you'll have to, this is incredibly not prepared, but and then you simply have the two backgrounds overlay one another, or half overlays, so you can scroll once, and then for every frame you draw all the 3D stuff with you first have to set the viewport stuff so it automatically discards the stuff out of the viewport or outside of the viewport. I think with the display capture, you will only transfer a single block of pixels. So you would have to use horizontal splitting, not vertical, because it can't copy a single scan line, then skip the second half of the scan line, then continue copying the second scan line, and so on. And then, so yeah, every frame you render the stuff, it gets bumped into one of the capture VRAM banks. Then you switch the capture config and the 2D config to swap the banks that will be displayed. Then do the 3D rendering stuff again, so that now it will draw the new 3D stuff to the other bank, while the first half still displays the stuff that's saved to the background layer, and yeah, you continue from there basically.
So it's like back buffering, but in a more cumbersome way, with we're dealing with
basically.
the VRAM and all the switching around.
Yeah.
Sounds simple. It's easy. Just implement it. Make a demo about it.
Draw the rest of the fucking owl.
Yeah. Question by Evil: how many layers does the screen have in Amiga fashion? Does it have like different ones? I think you only have the 3D and the 2D effects, right? Or am I talking shit again?
You have 4. It's not like it's configurable like the Amiga. So you have 4 background layers, of which one can be a 3D layer instead of a 2D layer. And there's also a sprite layer. However, the sprites have a priority bit, so you can actually stack them on top of each other, or between one of the background layers, or completely behind or completely in front of the background layer. So you can play with that a bit, and you can also fake a few extra layers with the 3D engine if you need more of them.
Nice.
So yeah, you have like 3 plus. So that's 3 plus 4 plus how many you can fake with the 3D engine. So
That should be
quite a
enough for
bit if
anyone.
you're a
Yeah.
creative.
Yeah, it should be enough for anyone. That's actually pretty impressive. I thought it was more limited than that. So that's pretty cool.
Yeah, I
Um,
mean now I'm talking about how to implement the all those checkerboard layers like I did on the Amiga on the DS, and how many layers you can do with that.
yeah, that would actually be an interesting effect to have, and you could use those different layers to do that trick. So okay.
Yeah, although now that I think about it, the CPU is probably also fast enough to render a lot.
Just render everything. Yeah.
Yeah,
With the CPU
just
itself.
to use software rendering, because uh, you need a multiply instruction for that. But the ARM has a fast multiply instruction, so it completes in like 1 or 2 cycles at 66 megahertz. It's fast enough.
Okay. Really cool. I have some generic questions here. Do you have any pro tips for new programmers who are getting to learn a new platform? Like stuff like the Nintendo DS can be a bit hard to get into if you're not, used to ARM and low level kind of stuff. So do you have any tips for people? Should they be focusing on engine or getting knowledge? Should they be focusing on getting something on screen? What would be your recommendation?
I have honestly no clue. I
So how,
started by
how
making.
yeah, how did you end up looking into the Nintendo DS? You already had a lot of prior knowledge on other similar platforms, right?
Yeah, years ago I played around on the GBA before I entered the scene, even. But of course I wanted to use completely 100% my own code. So I wrote my own startup code. I wrote my own interrupt handler. That's a huge time sink, so I don't recommend doing it.
But you learn a lot from that, right?
Yeah, I guess. From then on, I mostly focused on Linux scene stuff and other stuff I was doing. And then for Evoke 2018, I had the SDK already on my laptop doing absolutely nothing, but I said, okay, hey, how let's make a DS demo. How hard can it be? And
And the famous last words.
yeah, I made a really simple intro thingy for the alternative platform competition. Uh, it worked, I guess. Made it in a few days. It's a few polygons, not much else, but it works.
Okay.
And
Well, that's
and
great. I
from
mean,
there,
you tackled a new challenge. That's also important. Sometimes it's time to open a new can of worms and just get yourself dirty.
yeah, and for that, I basically used all the libnds stuff, even its GL library, which sucks. And then I thought, okay, that's not a good way to make DS demos. And from there, I made a framework that's a bit more usable with actual separate effect codes, and things that call back into the effect stuff. And then as soon as vblank happens, there's first some boilerplate stuff, and then it calls into a vblank event handler of the effect, etc., etc. And I first used that code for chimp cubed for Flash Party, which was also okayish, I guess. Then I used the same thing except with bug fixes, because there were a few bugs in the timing code. Because I didn't do the timing code correctly, so the audio and the video were actually getting out of sync back then, but I fixed it now.
Okay.
The fixed version I used for Kekse, which I entered it at Cookie 2018 in December in Paris, which was also not bad, I guess.
So you're getting your time to do like this big mega demo for the Nintendo DS. It's coming any year now.
Yeah, and from then, yeah, from there I was still using ADPCM playback, and I said, okay, no, my group actually had an MP3 replayer from a decade ago, which was used in numbering sucks, etc. So I put that one into my framework. I also started working on a Blender to the DSGPU commands converter, which is also kind of needed because uh, lots of stuff in Vikigso was still very hard coded, which made it a pain to actually finish.
Mm-hmm.
So with a very hacky first version of the converter script, I made the DSNIC thing. With the spaceship intro was
Yeah, yeah.
actually just a Blender animation ran through a converter and it worked, which was great. But well, it used baked animation, but it was completely uncompressed and it used a shitty format, so it was huge, even though it completely didn't have to be like that, simply because even constant values were animated, so it repeated every frame, which is not a good idea.
It wasn't very optimized, let's call it that.
No,
But you
because the night before I had to take the train to the party, I was still fixing issues in that exporter script with Blackall. So that was fun. And
Okay.
then, since then, I started actually focusing on finishing the exporter script and then finishing a tool for post-processing effects and looking at interesting stuff of the DSI hardware. And yeah, since then, I basically got into the black hole of working on that. And I was also working on Linux tooling. And also the semester began again, so I was busy with uni.
Yeah. It's
And then,
it's a marathon kind of process to do something
yeah,
good on a new platform. But you're learning a lot, and you've been doing this for 2 years now on the focusing on the DS. So you've been doing a lot of progress. So it can only get better.
yeah, I
So
guess, and, after a bit of radio silence, when, 1 week before revision, I had nothing. Asked around on Mastodon, hey, does anyone have an idea for a DS demo? And Halsey sent me this Blender animation with the UFO. And I still had the converter script lying around, which needed some bug fixing, simply because it was written to specifically work with the DSNIC animation. And after some hacking, it worked. So
okay, a lot easier to make stuff now that you already figured out all the other bugs. Anyways, I wanted
yeah,
to ask
but
you about the extras part because you did this extras. Should we play it now? Do you want to talk a little bit about it before we play it?
yeah, I mean, yeah, basically, like, one thing I wanted to finish about my Nintendo DS history. So yeah, right now I'm still focusing on tooling. I'm working on adding debugging support to Melon DS. Guess why I would use it.
Yeah, to debug stuff.
And yeah, and there's also ESI hardware stuff I'm still reverse engineering, and then I have to write drivers for them because some of the DSi hardware peripherals are actually really complex, unlike the DS. The Wi-Fi and the DSP are ridiculous, so that needs a lot of code. So there will be coming a demo that's not made within 1 week, but it'll take a few years.
It's a process.
Yeah.
Okay, so about the extras, do you want to talk about that?
I guess you can just play them because they're about some interesting stuff about the hardware, and you use it's very nice because it does not touch on the hardware stuff I have been working on. So I'm not disclosing any tricks that will be used in the upcoming emulator breaking demo.
Okay. I'm gonna play it now then. So be right
Okay.
back for extra questions if anyone has about the extras. So see you back in how long was this? About 10 minutes, so not that long.
Alright, looks like we have some time left, so here's the extra stuff I prepared. I actually have two challenges for the audience. One of them is about capturing Nintendo DS or DSi demos. Now, typically, audio capturing is easy because it has an audio jack. Video capturing is really hard because, the graphics hardware can only capture the output of one screen in software. Hardware capture units do exist, but they're really rare, really expensive. If you happen to have one, please contact us because there are loads of DS demos that need good capture, and emulator captures don't really cut it. So currently, people just place a camera physically in front of the console and hope the result isn't too bad, which it often is, so that's not really great. But there's also the 3DS, which has DS, or well, actually DSi backwards compatibility mode in hardware. It actually shuts down the operating system, then runs a special firmware which reconfigures all the hardware to set it up into DSi backwards compatibility mode, and then it's able to just run DSi software as if it's just a DSi. There's the special TWL firm, TWL being the code name for Nintendo DSi. So yeah, on the ARM7 and the ARM9, it simply sets up some stuff and then jumps into the DSi code. On the ARM7, there's a special process running called Twilight Background. What that process does is it starts a special DMA transfer from the legacy video output to the actual LCD controllers so that you can actually see the output. And that's actually a target here. It also does some other bookkeeping stuff, but that's not interesting here. So if you manage to take control over this DMA transfer, you can capture Nintendo DS and DSi demos perfectly. But how do you do that? You'll either have to exploit the Twilight background process, which is hard because there's no code running on the ARM11 you can control, or you have to re-implement all of the TWL firm code, which is also hard. But for the latter, there's actually it also has a GBA backwards compatibility mode, and for that people have actually re-implemented it. There's OpenAGB firm, so it should be possible to re-implement it, at least in theory, but it will still take quite a bit of effort. So here's my second challenge. I'm pretty sure I found a 3DS ARM11 user mode to kernel mode escalation exploit. I don't have the 3DS, so I cannot really test it, but someone might want to do this, I hope. So the way this works is, with all the DSi stuff that was reused in the 3DS, the DSi has DSP. It has, FIFO DMA thing, where the ARM9, or in the case of the 3DS, the ARM11, writes to a memory port of the DSP, and it will magically end up writing stuff in the DSP memory map, which is useful if you want to send a few values for a message like, hey, start doing this stuff, or things like that. Now, a few weeks ago, I discovered that you can set this DSP transfer thing, because you can set it to read or to write, or you can because the DSP has separate memory maps for code and data sections. You also have settings for that, and there's an undocumented transfer mode 7, which actually, with some extra setup, is able to loop back all the transfer to the ARM9 bus, or ARM11 in the case of the 3DS. So you write to these magic ports, and then a write happens, which is kind of useless thing because the ARM11 can just write stuff directly. Why would you do it otherwise? But on the 3DS also has a DSP, but the 3DS actually has an entire operating system with a kernel and games running in user space with an MMU in there, and these writes caused by the DSP DMA don't care about the MMU. So you're actually, if you manage to use these DSP DMA writes, you can actually bypass the MMU and then you can rewrite kernel code, and yay. But why this would be useful? There are of course already kernel mode exploits for the 3DS because it's already been out there for 10 years, so why wouldn't it? But the kernel memory lives in a separate RAM chip. There's the FC RAM, which is like 128 megabytes of RAM where all the game stuff is. There's a special XCW RAM thing where all the kernel is, and there are a few exploits that misuse GPU DMA to override code that stuff that shouldn't be reachable from user mode, but the GPU only has access to the FC RAM and not to the kernel RAM, so that's a problem. With some really interesting vulnerabilities, it's possible to build a chain of exploits to eventually end up being able to run code in kernel mode. So this exploit would make this much simpler, but there's of course a catch. The 3DS operating system uses a microkernel, so all the drivers are separate processes, so you can't access the DSP ports directly because you have to go through a DSP service, which is basically a driver. So either you have to exploit the DSP service by using a buffer overflow or something in that service, or you could use one of the existing exploits like GPU DMA thing to rewrite the DSP service code so it will happily execute things you want instead of the usual stuff. Also, the DSP service checks for, it's also responsible for uploading code to the DSP, and it actually checks if these binaries are signed by Nintendo. So if you want to do DSP stuff on a 3DS, you'd have to get around that, which is, I'm not sure if there's a way to do that yet, so there's another reason to try to find a vulnerability in this DSP service. So yeah, maybe you can use a GPU DMA exploit for that. So here's the info on how you do it, and that's about it. Thanks for attending.
Okay, let's give Poro another call just to wrap things up. If anyone has any final questions, please let us know now before Poro goes to bed. Thank you so much for this presentation, Poro.
I'm not sure I'll be going to bed that quickly because my sleeping schedule is a mess.
That happens to the best programmers out there, and the worst as well. We were talking about how much do secondhand 3DSs and NDSs cost these days. Do you have some values from the top of your head, or should we be searching this on eBay?
Good second-hand 3DSs are usually around 100. In the Nintendo store actually has a list of refurbished second-hand consoles. Those should work like new, and they are pretty cheap. So you should look there. They will come with latest firmware most likely, but with the jailbreaks, that's not much of an issue.
Jailbreaks
As far as I know.
affect the latest firmware as well. They didn't patch for that.
There's not so long ago. There's a new version of the 3DS browser hacks released that works on all firmware versions. I think. I'm not sure. So you should check it.
Yeah, check before buy.
I think it should be okay.
Okay.
DSIs, you can get them. Yeah, for DSIs, I know pretty well. You can get them for like 30 euros, simply because I had to get one, another spare one to do hardware experiments on. I have some screenshots of that. Maybe I should post it.
Yeah, please do. Put it on the chat.
If I can find the links. Yeah, I'm doing that sort of stuff.
30 euros or $30, pretty cheap for handheld.
Yeah. For the regular DS, I don't know it out of the top of my head, but you can also just get a DSi. It's the same functionality, except with a bit more stuff, and also a slightly better battery life, I think.
Okay. Anyone else has any questions? Otherwise, I'm going to wrap up this seminar section, and we're going to keep the live stream going with some more demos from Chaos Constructions. But for now, thank you so much, Porocyon, for your seminar. It was very insightful. I learned a lot about the NDS, and I think people on the chat liked it as well. So thank you very much for your submission, your participation to Seminar September that we've been organizing at Inertia.
Thanks, I guess.
Okay, I don't see... Yeah, people are just saying thank you. No additional questions. Okay, so let's go back to playing some demos. Thank you, Porocyon.
I actually do want to see someone trying to attempt to solve my challenges, though, but I don't expect it that quickly.
It would be nice to see more stuff done with the NDS. Your challenges were to jailbreak it, was it correct? I don't remember exactly. There were two of them.
Well, one was for the NDS or DSi captures on the 3DS, and one was for one way to make an exploit that's part of jailbreaking a 3DS.
Okay.
So yeah.
Okay. Bye bye. Yeah. Okay. Back to demos. This is Chaos Constructions 2014, or the invitation to Chaos Constructions 2014 by Z Brothers. Okay, I'm a little bit confused because this was already the next demo that I wanted to play. So did I skip through the Chaos Constructions invitation itself, or did both of them play? I think I only played Cheshire. Cheshire was actually the winner of the combined demo combo. It was 64k intro by Z Brothers. So I don't know. I guess we skipped the invitation. Anyways, let's move on. This is Spirello. It won the 256 byte compo at Chaos Constructions 2014. It looks a little something like this. It's pretty cool. 256 bytes. Moving on, we have another thing that's also quite interesting. It was a wild demo. It's called the fourth demo tool. And I just fucked up something on the presentation. I'm gonna do this instead.
Пал 5 JavaScript.
В 1971 году. Маленьким ходом.
Okay, so this is a Manwi's kid, and I'm not sure how many years old he was at the time, but he just did a fourth compiler to do a force translator to do graphic stuff because he could, and this was fucking awesome. It's a shame it doesn't. I'm not sure if there is subtitles in English. Is there? Let me check. Subtitles, auto-generated. Nope. Same, but it's really cool. I wish my kid will do force translators when he's this old. He's probably gonna just want to play Fortnite instead. Anyways, it was really cool, but since we don't understand Russian, I'm gonna skip to the next one, which is a ZX Spectrum demo by Kpaku, and it's called Kpaku. Kpaku by Kpaku. Or Kpaku by Kpaku team. Okay, that was Kpaku by Kpaku team. Next up, we have the winner of the combined demo compo for PC. Supervenience by Z Brothers is actually a 64 kilobyte intro. This is already Chaos Constructions 2015. really cool 64K there by Z Brothers. I don't think I've seen this one before, at least I don't remember it, but it was really cool. Nature-based, a lot of well-done effects. Pretty cool 64K overall. Next up we have the battle for the 256 byte compo. I picked 2 entries. The first one is Electric Force by Realm of Illusion, which is for the Vectrex, I believe. I think it doesn't have sound. Or maybe it does. They had a few bytes left. They could have done more. Yeah, it's pretty cool. Pretty cool Vectrex entry. So this got second place at the combined 256 byte compo at Chaos Constructions 2015. First place was this entry by a bot surfer of Red Sector Inc. called Centurio, which was pretty darn cool. At the time, there weren't many people doing 3D on 256 bytes, so this was quite impressive. Next up, we have AWAS, which was the third placed demo from the ZX Spectrum demo compo, which was a pretty cool packed compo this year again for the ZX Spectrum. So we're gonna play 3 free entries from that. pretty nice Spectrum demo, this one. A lot of 3D stuff, which for the Spectrum is mind-blowing. Next up we have the second place entry, is called Pre-Calculated, and it's by Screw You. Some conceptual stuff. Screw You got a lot of hate for doing abstract minimalistic stuff, just converting photos, so this time was a bit taking a bite out of that. Anyways, Paco Deluxe, the deluxe version from the last year demo. This won the ZX Demo Combo in 2015. Not over. Really great demo. Full of multicolor tricks. I believe this only works on a pentagon, but still, like, you could see some characters and especially like the diagonal parts where it's impossible that that's not like 4 colors happening on the same character limitation. So a lot of trickery gone into that to bypass those limits. Great stuff. Anyways, this was the winner of Chaos Constructions 2016 ZX Spectrum demo compo. Next up, we have 256 bytes that also participated. 2015, actually. Yeah, 2015. We have the winner of the 256 bytes for the ZX Spectrum compo, which is this effect. And then we're gonna move on to 2016. With sound. crazy stuff. Love what they do with the Spectrum in Russia. Anyways, let's move on to 2016 now. First with the winner of the 256 byte intro for DOS. It's Quattro by Desire and Sense Install for effects in 256 bytes. Pretty extremely impressive when it came out, because it's only 256 bytes. How the hell do they have 4 effects in there? It's pretty darn cool. And then we're gonna take a look at Breakspace, which got second place in the ZX Spectrum demo compo. It's by The Super. Okay, that was Break Space by the Super. I think it's pretty much Kapaku people, but with another name. Really cool demo. It's also compatible with the standard 128K, with some slight differences. Anyways, on number 1, a very close compo was Across the Edge by D-March. So yeah, another very cool demo. It was a very close compo. They ended up winning D-March. But yeah, both of them really cool. Oh, there's a second part. My bad. now it's really the end. So that maybe there was that second part that made all the difference and let them win the demo combo. Anyways, moving on to Chaos Constructions 2017. We're about to watch Hull. I guess it's Hull 4000 by Sans. It got third place on the PC demo combo.
Wake up, Dave. Do you hear me, Dave? This mission is too important for me to allow you to jeopardize it. Do you hear me, Dave?
Nice stuff. This was actually a combined demo compo, and the winner of the combined demo compo was the demo for the Casio FX 9860G. Let's take a look at that by Eversoft. Cool stuff made for calculator. Now we're gonna move on to the ZX Spectrum demo compo from 2017. This is Asterisk by Screw You. Love Screw You. They're so anti-scene. It's great. They got second place with Asterisk. The first place was for Over Relaxed by Sip Crew, based out of Siberia. Great demo, winner from the ZX Demo Compo of Chaos Constructions 2017. Moving on to Chaos Constructions 2018. I think this is only credits, right? Yeah, it's a big scroller of credits. I'm gonna skip that because it's already getting late. Let's watch some Bad Apple on the BK0011. Okay, so this got second place at combined demo compo. Don't ask me why I wasn't part of the old school demo compo. And next up, I'm trying to watch CAC by Jetlag, which won the combined demo compo, despite being 4 kilobyte for Windows. I'm not sure if the playlist is correct. It seems to be. Really cool 4K by Jetlag there. Next up we have 2000 by Stardust. It's a ZX demo, which got third place. pretty cool demo. It reminded me a lot of TBK and 4D style of demo making. It was made in collaboration with some of those people, with some other people from Screw You. This demo was the one that won. It's called Aeon Demo, and it's made for a phone, which inside has a spectrum of some sort. Became a bit controversial because it wasn't like a real spectrum, but it sort of is a spectrum. And anyways, you know, Russian demo scene, it has to have drama associated with it. Anyways, you can flash the ROM in it and plug it in and see what it plays. Anyways, pretty cool demo. That was the last entry that I wanted to show from Chaos Constructions 2018. 2019 was a bit low on entries. I think the only one that is really worth showing is this one for the oscilloscope, and then STM32. So let's take a look at that, and that'll be the end of today's live stream. I guess I need to add this to my list of demos about space. Okay, that was it. Interesting stuff. So Chaos Construction 2019 wasn't that with that many releases. Not sure what would happen in 2020, but it got cancelled anyways. I think there will be a winter version. It got delayed somehow. Not really sure on that. Anyways, that's it for today. We're going to raid someone. I think Arctic is still doing stuff, so we're going to raid him. Tomorrow we have another live stream going starting at 9, Lisbon time zone, same as usual. will be the demo show from Wensley with curation by Mountain Bites people, another Swiss demo party. So enjoy the raid on Arctic. On Rone, he usually has some dope tracks for you. And see you tomorrow. Bye bye, everyone. Take care.